Yo! What is up, chat? Are we in the house or not? Are we gaming? We are here to do some skeletal animations. And this is gonna be tough as fuck. So let's put some focus music on. What's some good focus music? Shit. This is good. Let's get some skeletal animations going on. So I'm gonna read about it because I've never done it before. And after I understand the basics, I will be implementing it and hopefully, you know. The goal right now. Okay, so if I plan it out, let me open. Let me just. So, what the objective is. Shit, that is a bit. So, skeletal animations. What I want is to be able to load a skinned mesh. So for the verses we have like position, UV, normal, bones, and weights. After we have those skin meshes, I want to be able to have a simple animation playback. I want to be able to blend between animations. So I can go from like walking to running or idle to walking and etc. I want to be able to have a animation state machine. I won't have like any UI to configure it because it sounds like hell. Maybe even though I could probably do it with I'm GUI graph or something. But that is not the objective. So animation state machine, so I can have like an example graph. Example state machine. I can go from like walking, no, idle, to walking if W is pressed, idle, running or walking, running if shift is pressed, or we can just figure the movement out if on joystick. Yeah, and for the actual implementation, I want to be able to do skinning in a compute shader on the GPU, which should be pretty easy, thankfully, because you just move the matrix calculations on the GPU on your compute shader. And bitch, this is not Haskell. What? It's loading. No, no. Stop. Fuck you, Haskell. Die. There you go. This is not Haskell. This is Markdown. Thank you. So do skinning in the computer on the GPU, and you know, I think that's about it. Let's see. Alright, yeah, that's what I want. Let me just zoom out now. We can just do that. Bam. There you go. It was smaller, no? Yeah, it was smaller. Alright. Nah. I like Haskell. It's just that, you know, it's kind of a hog. Haskell is huge as fuck for no reason. And I don't know why. Like, GHC is one fucking nuclear station, like nuclear power plants. Like, I'm pretty sure when I compile Haskell code, it like mines Bitcoin on my GPU. Rewriting Lisp? Never. I've never actually like even like seen how Lisp looks like or works. I mean, I guess there's like a lot of parentheses, but let's go back to Firefox. Like, what's Lisp? Let's idiomatic Lisp code. Exactly, yeah, I think Haskell is a very pretty language, but gosh, is it fucking awful to maintain and actually write. This looks ugly. That's Clojure, it's not even Clojure. We're doing work, guys, by the way, we're doing work. Clojure. Do people actually use this? Where is Clojure used? OpenGL? Nah. Damn, yeah, that is not for me. Skeletal animations. So, yeah. 3D animations can bring our games to life. Objects in 3D worlds like humans and animals feel more organic when they move their limbs, do certain things like walking, running, and attacking. This tutorial is about skeletal animations, which you all have been waiting for. We'll first understand the concept thoroughly, and then understanding the data, we need to animate a 3D model using ASIMP. I use CGLTF, but anyway. I recommend you to finish the model loading section of the saga, as this tutorial code continues from there. You still understand the concept and implement it in your own way, so let's get started. So I already have model loading, so I'm guessing I don't need to do this. Interpolation. To understand how animation works at basic level, we need to understand the concept of interpolation. Interpolation can be defined as something happening over time, like an enemy moving from point A to point B in time t. What's IE? What does this stand for? IE meaning idest. It's Latin. Idest, translation happening over time. A gun turret smoothly rotates to face the target in idest. Okay, he really likes this idest rotation happening over time, and the tree is scaling up from size A to size B in time t. Idest, scaling happening over time. Bro is Latin. Okay. A simple interpolation equation used for translation and scale looks like this. Isn't this just like linear interpolation? Oh yeah, it is known as a linear interpolation equation, or LERP. I've used this before. For rotation, we cannot use vector, let me guess, quaternions. The reason for that is if we went ahead and tried to use the linear interpolation equation on a vector of x, y, z, the interpolation won't be linear. That's real. We'll encounter weird issues like the gimbal lock. Ew! That's the thing I've heard about. There was a guy in my chat who's like, oh, gimbal locks for the camera. But like, that's only if I use LERP, I guess. I don't use LERP for camera. To avoid this issue, we use quaternion for rotations. Quaternion provides something called the spherical interpolation, or SLERP. SLERP equation, which gives the same result as LERP, but for two rotations A and B. I won't be able to explain how the equation works because it's out of the scope for now. You can surely check out references section below to understand the quaternion. SLERP. Right, I totally get that. Gulp. Let's figure about it. Anyway. Rip along an arc. Ah, okay. Right, okay, that makes sense. Components of an animated model: skin, bones, and keyframes. The whole process of an animation starts with the addition of the first component, which is the skin, in a software like Blender or Maya. Skin is nothing but meshes which add visual aspect to the model to tell the viewer how it looks like. Just like the model, basically. The visuals, okay. But if you want to move any mesh, then just like the real world, you need to add bones. Just like a human being, basically. You can see the images below to understand how it looks like in software like Blender. This is the skin, that's the bones. Yeah, that makes sense. Okay. And I'm guessing that'd be something along the lines of like, when you move like this bone, it also moves the other bones or something. These bones are usually added in a hierarchical fashion for characters like humans and animals, and the reason is pretty obvious. We want parent-child relationship among limbs. For example, if we move our right shoulder, then our right bicep, forearm, hand, and finger should move as well. This is how the hierarchy looks like. Okay, that makes sense. Yeah, okay. In the above diagram, if you grab the hip bone and move it, all limbs will be affected by its movements. And I'm guessing that like if you move the hip joint a lot, for instance, your shoulder isn't gonna move as not the hip. What am I saying? Like your upper leg isn't going to move as much. So I'm guessing that like there has to be some weighting to make sure like it doesn't move like crazy. At this point, we're ready to create keyframes for our animation. Keyframes are posted at different points of time in an animation. We will interpolate between these keyframes to go from one pose to another pose, smoothly in our code. Below you can see how poses are created for a simple 4-frame jump animation. Sick. That looks sick. Okay. How ASIMP holds animation data. So this is not going to be really applicable for me, but I'll still read about it. We're almost there to the code part, but first we need to understand how ASIMP holds important animation data. Look at the diagram below. So AI scene, so that must be like CGLTF scene, I have the nodes, okay. And the scene has animations, okay. AI nodes. With, yeah, okay. Right. That's the, just like a GLTF node, okay. And an animation. Duration, ticks per second, and channels. Oh yeah. Right. Channels. Oh right, it's like the difference, like all the difference things need to interpolate in for the vertices. Okay, right. Okay, no, I get it. AI node NM. Okay. Just like the model loading section, we'll start with the AI scene pointer, which holds a pointer to the roots node, and look, what do we have here? An array of animations. Great. This array of animation contains the general information like duration of an animation, represented here as m duration, and then we have a m ticks per second variable, which controls how fast we should interpolate between frames. If you remember from the last section, when an animation has keyframes, similarly, an AI animation contains an AI node NM array called channels. Yeah, this array contains all bones and their keyframes, which are going to be engaged in an animation. An AI node NM contains name of the bone, and you will find 3 types of keys to interpolate between here: translation, rotation, and scale. Okay. Alright, there's one lesson we need to understand, and we are good to go for writing some code. Influence of multiple bones on vertices. When we curl our forearm and we see our biceps muscle pop up, we can also say that forearm bone transformation is affecting vertices on our biceps. Similarly, I can't read, bro. I am literally dumb. I cannot read. Similarly, there could be multiple bones affecting a single vertex in a mesh. For characters like solid metal robots, all forearm vertices will be only affected by a forearm bone, but for characters like humans, animals, etc., there could be up to 4 bones which can affect a vertex. Let's see how ASIMP stores that information. AI scene, AI mesh, AI bone. Vertex weights. Ah, okay. Okay, I get it. I think so. I think we get it. Offset matrix. What the fuck is an offset matrix? I'm scared. We start with the AI scene pointer again, which contains an area of all AI meshes. Each AI mesh object has an array of AI bone, which contains the information like how much influence the AI bone will have on the set of vertices on the mesh. AI bone contains the name of the bone, an array of AI vertex weights, which basically tells us how much influence this AI bone will have on what vertices on the mesh. Then we'll have one more member of AI bone, which is offset matrix. It's a 4x4 matrix used to transform vertices from model space over bone space. You can see this in action in images below. From model space over bone space. Okay. Bone spaces. The vertex on forearm in orange is in local space by default before applying offset matrix. Ah, right. Okay. Oh, okay, I get it. So, like, if you wanna apply a translation matrix to that specific vertex on the bone, you usually... Oh, okay, that makes sense. When vertices are in bone space, they will be transformed to their bone as they are supposed to. You will see soon. You will soon see this in action. Finally, let's code. Thank you for making it this far. We'll start with directly looking at the end result, which is our final vertex shader code. So this will give us a good sense of what we need at the ends. I can sense it's gonna be tough, but let's do it. Okay. So yeah, that makes sense. Okay. Max bones. Can't I could probably just do something like a structured byte address buffer or something. A structured buffer in HLSL for that. You can probably like upload the number of bones, I would assume. Oh, yeah, bone IDs, okay. Total position, max bone influence. So if the bone ID is incorrect, you just give up. If bone IDs I equals max bones, then it's just normal. Local positions equals final bone matrices. Total position plus equals local position times weights. Local normal equals matter free. Local normal? This isn't even used. What? This is not even used. Hello? I am so confused. Yo, Freak League guy, what's up? No way. The Freak Leaguer is in the chat. What's up, man? Wait, is the chat even... Can we even see the chat? Am I tweaking? Yes, we can, okay. Let me do it. A test. Test. Wow, it is impossible to read. It's fine. I'll just put it here. It's okay. Alright, fragment shader remains the same from this tutorial. Right. Right, okay, so... Okay, that makes sense, so just normal. What up, gang? What's up? Starting from the top, you see two new attributes layer declaration. Bone IDs and weights. Uniform array final bones matrices, which stores transformation of all bones. So I'm guessing this is the skinning part, right? Yeah. So like if I wanted to do it, like if it's uniforms, I'm assuming he's gotta do it on the CPU. So we can do it on the GPU instead. Like have a scanning pass before we draw the geometry. We just like take a structured buffer or something, and then we just pass it in. It works. Yeah, I think that's it. Which stores transformation of all bones. Bone IDs contains indices which are used to read the final bone matrices array and apply those transformation to pos. How do you even read this? How would you pronounce this? Pos. to position vertex with respective weights stored in weights. This happens inside for loop above. Now let's pause. Okay, fair enough. Now let's add support in our mesh class for bone weights first. Max bone influence 4. Alright, so back to VS Code. Okay, so I'm tempted. Well, not for now, but when I finish skeletal animation, I'll have 2 versions of this for GLTF skinned vertex and GLTF vertex. So I'll just put it here, but we'll see later. So max bone influence 4. So I'll just set it to 4 as well. GLM IVEC 4 max bone influence, and GLM VEC 4 weights. Wait, they don't love you like it. Alright. We have added 2 new attributes for the vertex, just like we saw in our vertex shader. Now let's add in GPU buffers, just like other attributes in our mesh setup mesh function. Thankfully, I have reflection, so normally I don't give a shit. So normally, if I just go into trivert and I add my floats, no, it's int4 bone IDs, bones, and floats for weights. Can just build and run, and that should be fine. Okay, cool. Look at this little guy. Look at this handsome little guy. But yeah, it's maximized. Oops. There you go, that's better. It's hiding my stuff. What the fuck? There you go. More visible. No one can see all the overlay. So this is the mod I'm gonna use, by the way. It's currently displaying the normals. I do have some textures, but like they're just random textures I took. And I think I did like a random idle animation. Yeah, it's my banner. I took a random idle animation from Mixamo, which should normally look like an idle animation. Just like before, except now we have added 3 and 4 layout location IDs for bone IDs and weights. One important thing to notice here is how we are passing data for bone IDs. We're using okay, blah blah blah. Let me just put Firefox back. We're using GL vertex attribute I pointer, and we pass GL and test third parameter. Now we can extract the bone weight information from the awesome data structure. Let's make some change in model class. Actually, gonna just put my fucking display. Yeah, I just yoink yoink yoink. Now we can see if I alt tab and shit. Yeah, okay. Now it's better. We just close this. There you go. Okay. So bone info and model is gonna have bones with names. Okay. Guys, did you know that std string actually causes a memory allocation? I never knew it before. And also, thank you for the follow, Mr. Rydog. Alright, get bone info map and bone counts. Set vertex bone data to default. Okay. Yeah, dude, crazy. I always knew. Because, like, it's like a security thing to avoid indexing it to a null pointer. So yeah, it does a duplicate. Shit, that looks hard as fuck. I'm not gonna lie. I can't lie. This looks hard as fuck, bro. We'll do it though. We'll do it. Okay, so bones. We have our bones. It's in the model, right? Do I need an unordered map? I like C++, but like I only do C style C++ because using actual C++ makes me want to kill myself, genuinely. Like, bruh, object-oriented programming is so ugly if you do it wrong, and templates suck. Like, it's slow, it's sluggish, it's unreadable. Like, we're at a point where modern C++ is less readable than Rust. Which is like, it's an accomplishment in itself, in my opinion. So now we have an ordered map with a string and a GLTF bones, and a bone counts. Why am I running it this way? What am I doing? Never mind. I'm done. Yeah, I mean, I also would use C, but I'm GUI too much. Yeah, Unreal fucking sucks. I legit do not want to ever touch it, but I'm gonna have to at some point. But I don't want to. I don't wanna. Set vertex bone data to default. I could just, like... inheritance trees. Yeah. I know, right? It's so funny. I'm not gonna lie. Yoink. Whoops. I mean, it's just... Do I really have to do this? Like, make it an actual... Bruh. Fine. I'll do it. Web dev. Web dev. I can relate. Yeah, I fucking hate web dev as well. Like, it's my least favorite thing ever. Like, I've done fucking functional and stuff, and that was cringe. My portfolio, bro. My portfolio is literally like 100 lines of code of HTML. It's nothing serious. Like, it's practically nothing. Alright. Here, we extract bone weight for vertices. Yeah, I mean, neither. I don't get frameworks. I don't know why. So, what I'm... Okay, and we do, like, the default one. So we do set bone default vertex. This is just normal, okay. Look at this handsome little guy! Oh, look at him! Oh! Anyway. Exactly, you need to use Angular version 15 and combine it with Rust, Zig, Tari, Bun, MetaQuest VR2, Odin, plus Unreal Godot Pro Premium++, combined with Unity's just-in-time compiled C# language server, TypeScript, accelerated CUDA, machine learned big data blockchain, hooked to a skibidi toilet language. I don't mind Bun. I think Bun is great. However, Zig can go suck a dick. I hate Zig. I hated Zig. I really tried, but I didn't like it. Music? Thank you. I really did not like writing Zig. Because, like, for me, okay, so for me, a low-level language is only a low-level language if it has some native bindings to OS APIs. If it doesn't have it, then it's not a real language. Yeah, it is a big nothing burger language. For me, like, I don't see the points. Like, I really like the fact that we're pushing, you know, actual memory arenas, like, in the actual, like, language. But I feel like no native access to OS APIs is like, well, now I can't write games in it. It's gonna be a pain. It's something that I don't have a problem with Odin and Jai, because Odin and Jai do have native bindings for the OS APIs. For most of them, actually. For Mac, Windows. Like, because, you know, it was thought of as a low-level language. Low-level languages, they actually do stuff low-level and give you access to OS APIs. So, of course, you know. That's just my opinion. And we'll also add a void set grips bone. It does, but not natively, in my experience. Zig Win32. Yep, you have to get them yourself. And you have to use like the fucking build.zig.zon, which looks absolutely horrible, in my opinion. Like, how am I supposed to... Like, what? Why do I have to put the license in? I just want to put my... That doesn't make any sense. And everyone's the same, right? I watch his videos a lot because it's super funny. Cakes. Zig. Look at him starting to get ready broken. And never banana.
Bill can't even open a window, man.
Can't even open a window! I can't open the window! Ah!
This is painful. Yeah, what am I doing wrong? I followed the
It's so German. Like, you can, like, hear the German
tutorial to a T.
word. And not only that, but, like, when he gets mad, he gets German.
I gave up for build system has walking away. Did we get the unstable master
Let's watch him getting
version? No, we didn't, right?
Imagine.
Zig. I'm sorry. Master. We got master. Why is it at the top if it's unstable? Why do you
Unstable! I love this guy.
put something unstable on top? It should be at the bottom. Oh my god!
He's upset. I'd be upset too. Yeah, exactly. So for me, if your language needs to have C underlying, no. If you need C for your language to work, to do low-level stuff, it's not a low-level language. It's a wrapper. It's like a scripting language. Like, bro, this is... It doesn't make any sense, you know? Unstable. I love this guy. He's so funny. He's the most game dev... Like, he's the most indie game dev out of all indie game devs. Because, like... I just want to make my game type of guy. He's not like, work-life balance, because if you want to see like a work-life balance guy, you gotta go and see Finn Matrix. And this guy, like, look at this guy.
Hello everyone.
Like, bruh. And he's also German. Well, no, he's British, but he lives in Germany. He's in Hamburg. Like, bro, this is the same country. Like, look at the difference between the Von Stable and hello everyone, welcome to this game tutorial. Dead. Anyway, back to coding. I am so dead. Yeah. It's fine, but I have a lot of time. You know what? Fuck it. Like, I can just copy this, honestly. I understand how it works. It's like pair programming with you guys. No way. A follower noise? One shape. Dude, I need to ask him. I'm on his server, I think. Am I? Yes, I am. Hold on, where is it? He's streaming as well. We'll rate him after. I like this guy. Bunch table. Anyway, extract bone and wait for vertices. We'll take the scene as well. Oh. Wait, so here in GLTF scene, extras. What the fuck is extras? Name, extensions, animations, perhaps. Node. Skin. That's okay. Weights. Is that the actual animations? I don't know. Skins. Okay. Skin. What? Wait, what? Dude, I remember I saw like a super cool graph, like just a really cool looking. No, not this. Overview. Quick reference guide. There, that's what I saw. Okay, cool. So, scene, node. What? How do you have the animation? What? Okay, let's go. Animations. Okay. If I go in assets, GLTFs, XBot, and GLTF, where are the animations? Okay. So they're part of the GLTF, so where... Yeah, here I have everything. Path. Gosh, this is long as fuck. And interpolation, okay. Inputs. Jesus Christ, okay. That's cool, but again, CGLTF is not making this better. This tiny GLTF maybe make it easier. C++11. Animations. Right, example test and so no, it's not tested for animations. Okay, let's do simple research. ASMP licensing. What's the license? That is a lot of yapping. chat. Oh, it's a custom license. I'm gonna kill myself. Okay. ASIMP. Liberal BSD license. Dude, I'm 80. I'm 18. I don't know shit about fucking legal. Liberal. Those fucking CC liberals. Anyway. I'm sure you can give me the animation stuff from CGLTF. Surely. Surely. Right? CGLTF animation. But do you support animations? My question. Animation. Okay, it does support animations. Cool. But how do we get it? Yeah, fuck ASIMP. I hate ASIMP. Also, ASIMP has like super bad PBR support. I hate it. I do not like it at all. GLTF tutorials, great. Animations. Cool, but like... But what's this? And skeleton is a pointer to a node? But how do they get the animations? Am I dumb? Name nodes. Okay, that's not really useful. Surely someone has used it before. Viewer. Does this use CGLTF? Okay, do we have animations here? Grid. We are going balls deep into this. Channel. Animation. Okay, so it does have animations. Sample shading. Interesting. Okay. Load images. Okay, cool. Why is it even 16 by 16? I'm so confused. Anyway. Materials. Okay, materials. Cool. Can we... Bruh. Oh, I just... Okay, that's useful. So how do we... GLTF init mesh, okay. Init, okay, that's... Bruh. But this isn't CGLTF as a init channel. CGLTF animation, but how do you even get to this point? In a CGLTF animation, but where do you get the CGLTF animation is my question. Am I using like an old version of CGLTF? I might be actually. Look at the new one, like the actually new one. CGLTF, where are you? EXT. Maybe it is a new one. Never mind, it is not new. So where do you get the CGLTF animation? I want it exactly. Okay, so here we have, okay, animations, and where do we get that? In the data file. Oh, that makes sense. Okay. Right, okay, I'm dumb. I am dumb. Yeah, FBX can go suck my nuts. I fucking hate private stuff. It's not open source. FBX sucks. Yeah, no. Bye. Okay. So the animations are here, cool. So extracts bone weight for vertices. Bone info, new info. Mesh bones. Bone index bone. Okay, question. So in my primitive, do I have bones? Primitive Attributes? Mappings? What's mappings? Targets, maybe? No, that's more targets. I'm dumb. So just, do we not have any bones in here? Or is the bones part of the node? That might be the case. Dude, this is fucking hard. It would've been easier if it was just async, but async is, yeah, icky. At least now we know where are the animations. We just want to like get the bones. That's what I want to say. What we want to need. What we need is the bones. In the AI scene. Auto weights. Mesh and bones. Weights. Huh. So I'm assuming it's in the node, alright? Node. Okay, we here have the weights. Skin. Skeleton? What is it? Okay. That's animations. Okay, how do we get the weights and the joints and stuff? I guess we'll never know. Cool. It's not in the actual file. Great. Okay, no, it is here. Skinning matrix. Joints matrices. Okay, but how do you load them in? Like, where are they? Position or way attributes. Dude, I'm so fucking stupid. It's an attribute. I'm so dumb. What am I doing? Of course it's an attributes. Right. Silly me. Attributes. I forgot, right, because if you're going to the CGLTF thing, assets, GLTFs, exports, we'll see like weights somewhere. Yeah, there you go. Joints is 0 and weights is 0. We'll start with joints and we'll do weights as well. Joint attributes and weight attributes. Joint attributes equals primitive attributes I. And it's weights 0, I think. Weights attributes plus primitive attributes I. Alright, and we're gonna do a little actually no, we don't test it, but I think we can like if joint attributes or if weight attributes no error, we can find the joints and weight attributes. Builds, run. Okay, so it does find it, cool. Right now, I guess there's just... Can I just like read it? That would be crazy if I could just read it. Bone info map, dude, that is crazy. Bone info map. Jeez. Or is it already applied? Like, can I just load it in? We can go for it with a debugger. Let's actually do that, it will be easier. Let's get those assets and shaders and put them in the run tree. Assets, shaders, yoink. Alright. So let's go here. Okay. So joint attributes, it is found. Type. Okay. Data. R8U. vec4. Okay, so it's just a vec4. Count. Buffer view. Wait, so is it already pre-computed? That would be super sick. Actually, that would be pretty sick. What about weights? R32F. Uh-huh. Okay, so joints is an R8, which, you know, be careful. R8U. A U8, this is an F32. Okay, so what we're gonna do is U8 IDs 4. So here we can read this in. Joint attribute data. Vertex, this is gonna be just plain old IDs, and there's gonna be, what? Oh yeah, it's not read float, it's read UINs. Read doesn't like it. Element size 1. This should be right, I think. I actually don't know. Like, what does this do? View data, read UINs. That's a stride. I guess we'll just fuck around and find out, shall we? And this is floats. It's not joints, it's weights attributes data. We need the value pointer of vertex dot weights. I trust this to be correct. Oh wait, it's not a vector. I can just do this. Doing okay. Cool. So here it still loads and compiles. Here I should be able to do IDs, vertex dot maxbone influences. Invalid. What? Oh yeah, right. Silly me. I don't like Rust. I don't like anything actually. I don't like anything. I'm a hater. Alright, let's render dog this. F12. Let's see what's in the data. Alright, draw index. Okay, so this is GUI. Okay, this is the interesting. Okay. Whoa, okay, this is, so the weights, this looks okay. Oh, what about this? I can't tell if this is right, actually. But this definitely does not look right at all. This does not look right. Nah, I love C and C++. I love writing C++ in the style of C. And I love C. I just don't like all the modern, like, trendy languages like Zig and Rust. I do like Odin and Jai as well. I think they're cool. Especially Odin. I really like Odin. My only issue with Jai is the fact that like there's no LSP for now, so it's kind of a pain to write for me because I'm a baby programmer. I need my LSP. Okay, so the bones definitely seem wrong, which I'm not surprised. I guess this should be 4 then. Language server, basically. It's like the code completion, like IntelliSense. Yeah, language server protocol, I think it's the acronym. There's not one for Jai yet. There's one that is currently in the makings, but like it's not official. It's called Jails. Jai language server. Alright, let's try it again. Okay, this looks more like it. This looks more like it. So we have the bones. Can the bones be negative? Am I seeing minuses? No, okay, I'm just stupid. And the weights they seem okay as well. Okay. Yeah, I'm part of it. I don't use it a lot though. If not at all. I use it a bit. And I was like, okay, that's cool. But like, I don't really have a use case for it. Like if I'm gonna write a game, it's gonna be C++ anyway. Because most libraries are in C++. Like I have like navmesh in C++. I have native mGUI. I have a lot of useful stuff. I'm mostly waiting for it to actually come out to use it. But right now, yeah. I've used it before though. And the funny thing is I got it. A fix will know probably how I got it, but basically I got it by working with Randy, because I applied like twice to Jai Beta and I got ignored like every time, and then Randy wanted me on the Arcane project. He'd be like, oh John, do you mind letting this guy in? And he was like, oh sure. That's how I got in. Whoops. But yeah. Randy is definitely the guy of all time. Okay, so I think we have our things now. We have the joints and the weights. So this is le bullshit. This we don't actually need it because it was already in. Which, great, you know, it's cool. Or does it? I hope it does. We'll see. We will see. We will see in due time. Okay, so this is the explanation for everything. Right. Should we read it? Wait, do we actually? Oh yeah, we do read the bone matrix. Right, we need to extract the bones. That's true. Fuck. Bone info map. Bone ID. Bone counter. Bone counter plus plus. Jeez. Okay. Let's make it easier. I think it's in the node. Which, you know, thank fuck. It's in the node. Switch to countdown page. I'm thinking bullshit. Also, the code name is so weird. Like, what the fuck do you mean ounces? Hello? Ounces? Excuse me? Name. Joints. So I'm guessing the inverse bind matrix, the offset matrix. I guess so, but like still. Doesn't make any sense. Yeah, okay, so this is the offset matrix. It's called a joint matrix. Where each node whose index... Wait, I need to compute it myself? Oh god. Jeez, okay. Well. Global joint transform. So I need to get the joints from the node up. Wow. Yo, not gonna lie, Asimp seems great right now. We'll get it to work, guys. We'll get it to work, surely. For each node whose index appears in the joints of the skin. Let's put some... Transforms the mesh from the local space of the joints based on the current global transform to joint. It is called global joint transform. Oh. I mean, I was told that I was gonna, you know, do something really hard, but you know what? I don't care. I'm gonna do it. Like, I'm sure I can do it. Believe in myself. This is loud, by the way. There you go. The data of these accessors passes attributes to the vertex should be with the joint matrix array. There's 4 of them only. I'm guessing the joint is the skinning. Oh yeah, okay, that's the skinning of the mesh. That makes sense, okay. So this is... okay. So I need to create the joint matrix. That's something I need to actually create, which is in the bones. Because I looked at like a blog post from a guy that I know in Wicked Engine. There you go. Who has animations? Look at this guy. Anyway. Okay, now we have the bones. Pose 0, I'm guessing, is the scale. Jeez. Here's the skinning thing, okay. Stride. Okay. Okay, so it gets the normal, the position, and the tangents. Makes sense. Because yeah, he packs it. Okay, yeah, he has vertex compression. And I don't. So far I don't need to worry about this. Yet. Dispatch. Yeah, okay. This is why I predicted this would be taking a lot of time, but we can do this. Okay, so we have the joints and weights. Now we need to extract the bones. The bones is in the skin, or is it? Node. Why is there a weight array? I'm confused. Oh right, the skins. Wait, so there's weights relative to the bone and weights relative to the entire skeleton. I assume. Yeah, that's probably it. Okay. Why doesn't learn open geot? You know what? Let's actually read the part where he does the extraction. We start by declaring a map and bone info map and a counter and bone counter, which will be incremented as soon as we read a new bone. We saw in the diagram earlier that each AI mesh contains all AI bones, which are associated with the AI mesh. The whole process of the bone weight extraction starts from the process mesh function. For each loop iteration, we're setting m bone IDs and m weights to their default values by calling function set vertex bone data to defaults. Yeah, we did this. We did this already. Just before the process mesh function ends, we call the extract bone weight data. In the extract bone weight data, we run a for loop for each AI bone and check if this bone already exists in the m bone info map. Okay. If we couldn't find it, then it's considered a new bone, and we create a new bone info with an ID and store its associated offset matrix to it. Then we store this new bone info in n bone info map, and then we increment the n bone counter to create an ID for the next bone. In case we found the bone name, then that means this bone affects vertices on mesh out of its scope. So we take its ID and proceed further to know which vertices it affects. One thing to know is that we are calling asim map, okay? Asim stores its matrix data in different format than GLM, so this function just gives us our matrix in GLM format. We have extracted the offset matrix for the bone, and we will simply iterate its AI vertex weight array and extract all vertices indices which will be influenced by this bone along with their respective weights and call set vertex bone data to fill up vertex. Bone IDs and vertex weights with extract information. Phew, you deserve a coffee break at this point. Okay, so the joints and weights we read it in. It's probably like local to the bone, and we need to also do it local to the skeleton. Jeez, bro, this is tough. Wait, so what's the difference then? Because this is still... I am so confused right now. Do we have an animation programmer in the chat to help me out? I mean, I guess probably I have a Discord server. We can ask questions, and we have an animation guy that can help. But yeah, maybe at some other point. Let's continue reading and then we'll probably like do the implementation. High level view of classes. Now, question is, So the offset matrix that so-called ASM computes, is that the actual like inverse matrix? Like inverse bind matrix? Or is it like pre-computed? Because if it is, I'll be cheating. That'll be cheating. Because what do you mean I have to compute it myself? Not nice. So we have the animator, animation, duration, global inverse, bones, root node, animation path, model, hierarchy data, missing bones, find bone. Jeez. Okay, let us remind ourselves of what we are trying to achieve. Let's do that. For each rendering frame, we want to interpolate all bones in hierarchy smoothly and get their final transformation matrices, which will be supplied to shader uniform final bone matrices. Here's what each class does. Bone. A single bone which reads all keyframes data from AI node anim. It will also interpolate between its keys to translate. Okay, so this is used for the matrices, right? And it will do the interpolation. Async node data. This work will help us to isolate our animation from async. Okay. Animation, and that's which reads data from AI animation and creates an hierarchy. How do you even pronounce this, bro? English, French. Let me just do this.
Hierarchical.
Hierarchical.
Hierarchical. Hierarchical.
That is so weird. Anyway. This will read the hierarchy of async node data, interpolate all bones in a recursive manner, and then prepare final bone transformation matrices for us that we need. Okay, this is gonna be very tough. I still need to understand the whole, like, actually reading the matrices and bones and joints from CGLTF, because I'm not switching to ASIMP, because, you know, come on. So, oh, that's a GLTF bone. So what do we just do then? Oh well. Immediately gives me the Learn OpenGL guide. technical aspects, that's cool though. Okay, let's read this. This is a paper. We like papers, right? We like papers. Scene graph. Animating cube robots using them. Skeletal animation. Scene graphs. God. A model from a commercial video game. New concepts. Okay, this is what we want to learn. Modern video game characters are usually rendered by the movement of an underlying skeleton of joints, controlled by data loaded in from an animation file. Oh wait, I get it. Okay, so we can load the buffers. Wait, hold on. We load the buffers from the data, but we can also just get the file to get. Okay, so buffers is what holds the vertices, and file has all the animations and shit. Okay, I get it now. I get it. This makes them much easier to control and capable of much more interesting movement than the hard-coded animations we use for the cube robot. The skeleton used to animate a skeletal mesh is made up of a number of joints. Each of these joints has a transformation considering position or rotation, may have a parent joint its transform is in relation to. Sound familiar? Yeah, it's just like nodes, yeah. Each joint is essentially the same thing as a scene node. If you look at the introduction image, and even spotted transition joints, just like our cube robots, some skeletal animation meshes will have a node of local origin to aid in model placements. The joints used in meshes don't necessarily directly replicate low rail joints. No, how rail joints are used in the human skeleton. In a game, a character's face may also be made up of joints. Yeah, that's like morph targets, if I remember correctly. Joints driven by an animation finger. Let's move when talking. I need to look into this, by the way, because if this game ever gets somewhere, I want to have some mocap for cutscenes. And face tracking might be fun. Highly detailed game characters who turn their eyes towards you, they did so due to having their eyeballs connected to joints. Wow. Joints might also be used as attachment points. For example, as a character holding a weapon in a game, probably does so because the weapon mesh has been attached to a joint in the character's hands. That makes sense. You know, we should probably do before animations a scene graph. Fuck me, dude. We should probably do a scene graph before we do any of this. Maybe we should do a scene graph before. Okay, let's just read about it and we'll see. We're not in a rush. Skinning. If joints are just the same as scene nodes, how exactly is skeletal animation better than the primitive animation we achieved with the cube robot? The problem with the scene node animation is that every vertex is drawn in relation to only a single point of reference, the scene node itself. However, in skeletal animation, it is common to use a process known as vertex skinning, where each vertex position is built up from a number of points of references. This is useful for joints which rotate by large amounts. Take the elbow, for example, an image we wanted to build up a human model. Complete with fully posable arms. If you tried to stimulate the elbow joint, it would end up with something like this. Okay, that makes sense. Yeah. Okay. If we animated this elbow joint, we would hold the elbow. Not really. We try to fill that hole by making the forearm joint area bigger. Okay. single mesh for the entire arm, which has each vertex drawn in relation to multiple frames of reference. Two variations on using those points of references. So let me just test something, because like right now, if I go in Zonda, white noise, assets, GLTFs, export. Well, he's a bit rotated, but yeah, okay, he is doing stuff. He is a teensy bit rotated. Either way, okay. And here we can see the bones. Right, I should probably like try and extract the bones first, so I can then draw them to the screen. Using a line renderer, that'd be nice. To draw the bones. We'll do a debug render at some point. I already have one to draw lines. I mean, not in the game, but I know how to do it. So we'll do that. Single mesh for the entire arm, or even the entire model, which has each vertex drawn in relation to multiple frames of reference. Two variations in using these points of references. Each vertex has a position and number of joints. The position is relative to. Each vertex is relative to the number of anchoring points, each of which has a position and a single joint it is relative to. Right, okay. So there's relativity to the joints, and there's relativity to other points. So there is two weights. Okay, so there is more weights than a follower. There's weights between vertices and weights between bones. That makes sense. I think. Oops. The final position of the vertex is determined by its position in relation to a number of reference points. How much influence each reference point has in the final vertex position is determined by its weighting. Each vertex has a weight value for each reference point, which together add up to 1. These weight values are then used to scale the result of transforming an initial vertex position by joints transformation matrix. Jeez. Here are some examples to show how the vertex position is calculated using its reference points. Okay. Direct vertex weightings. Okay. Bind pose. Underlying skeleton rigging is usually placed into a bind pose. For bipedal meshes such as humans, or the Hell Knight used in these examples, the bind pose is to have the mesh legs slightly apart, his arms out to either side. Easier to access individual vertices when modeling, and also to place the mesh in a fully stretched state, making it easier to weight each vertex to the correct joints. When noting in skeletal mesh, if no animation is applied to it, it will most likely be in this initial bind pose states. Okay. So I think what we want to do is first extract the skeleton and like display all the joints. Like display the bone. So what are in the bones? Oh right, dude, I'm dumb. That's the skeleton. And those nodes have a mesh. So actually what we should be doing, instead of loading like just the meshes of the nodes, yeah, this is only for, you know, like normal meshes, but skin meshes we should be loading through the skin instead of the nodes, I think. Wait, did I change the stream title? I probably didn't. Yeah, I didn't. Day 3. Wait. The skin mesh contains a position attribute that refers to the axis here for the vertex positions, and 2 special attributes are required for skinning. So the indices of the joints that should affect the vertex. Weights is your attribute data. It defines the weights indicating how strongly the joint should influence the vertex. In this information, the skinning matrix can be computed. Right, okay. This is crazy. Okay, let's look at the nodes first. Scenes. Okay. There's a tree, okay. A node may contain a local transform. Translation rotation scale. Okay. Each node may refer to a mesh or a camera, using indices that point to the meshes and camera arrays. These elements are then attached to those nodes. Okay. Nah, hell no. Never. ChatGPT, nah, never. I will not step that low. Well, I guess I could ask him questions, but I trust myself. I'm super thirsty. Do I have some water in my room? I do. LFG. Drinking sound intensifies. Okay. Okay, so the mesh has the skin, and the skin has the info on how to skin the mesh. This is not confusing at all, by the way. No, but I get it, I get it, I get it. I think I get it. It's gonna be a while. Okay. The meshes have primitives, which are the triangles, okay. Rendering mode. Okay. Morph targets. Okay. Okay, so we still have this, but let's just forget about this. Alright, also let's ditch the demo window. Main, where is our main? It's here. Demo window. Fuck you. Let's do instead. Okay. Actually, no, I don't even need that. What am I doing? I'll just set to wireframe all the time. Okay. So we'll do if draw mesh. Put all of that. Then we'll have our if draw skeleton. Draw lines, bruh. And here we'll do. What does this return? Returns false. Okay. We'll just do if I'm GUI is window focused. I'm GUI focused flags. Any window. Use IO won't capture mouse. I'm GUI IO. I'm GUI. Get IO. We'll just do if IO that won't capture mouse. And just remove this. Okay, let's try again. Okay, cool. So now we need to actually draw the skeleton. But how do we do this? We'll find a way. We will find a way. Also, let's make it not completely black. Let's make it a bit different. Let's make it white. Why not? Also, white is a vibe. I don't know about you. It's a vibe. Except when it's focused. I can't see anything when it's focused. Better. Okay. So I think we can just like put our yeah, I mean we have the bones here anyway. So we should probably extract them. Rotation scale translation. And here we can go back to what we saw here. Except we just forget about this. Okay, so here, notes, process geometry. Process animations. Node, if node skin log found skin node skin name. Just armature. That's cool. That's not really useful. There's two armatures? Let's open up Blender. Why GLM with DX? Because DirectX Math is cringe. And if I ever want to port it to another API, I just need to use GLM. DirectX Math is just like C++ hell. I don't like it. I think GLM is more uniform and overall cleaner to use. I prefer the naming convention as well. But that's just me. So let's rotate him properly so we can actually see the guy. Okay, so now we see the dude. Okay. And he walks. Okay. So you have 2 armatures? That's the rig. Beta joints. So that's the actual geometry. Modifiers. Heck is a modifier? Vertex groups. God, it is hard. Okay. Let's try another model. Imports. So let's just yoink. We do not exist anymore. Let's try another dude. That might be easier. The cesium man. Good golly, you are small. You're a small man. Armature. And there's another armature as well. Look at this little guy. Okay, so let's load the cesium man first. We'll figure it out later. Look at this handsome guy. Is he textured? Do not texture him. Yoink. Better. Okay. So, Mr. Cesium Man only has 1 armature, which is this one, I assume. This is called armature, but it's actually just joints. And that's the geometry, I assume. What is modifiers though? Armature. Vertex groups. That is all the joints. Thank you, Eggplant, for the follow. Appreciate it. Because this is like the joint hierarchy. So what we call the armature. Why is there spheres? Like actual geometry inside them to represent the actual thing that we don't actually draw? That would make a lot of sense, but icosphere. Right, so that's to reference, like to show the actual joints. To show that way, like where the joint is in relation to the objects. Delete things, like, whoa. Okay, here now I can see the joints. But they don't look really, okay. So they all point this way. Z up. So if we go into animation, to the pose position, please. Now you see them moving. Can I like make it loop? That'll be fun. Playback. Doesn't seem like I can. Okay. God, that is cursed, bro. That looks cursed as hell. Can I do it with the little... The X-bot? Gosh, you're one huge motherfucker. So, as I was saying... What? Whoa! Massive ass joints, Jesus Christ. Maybe I should have kept the scaling. Wow. So if it's this huge, without the isosphere, how is it with? I need to see now. Because this must be insane. No, not FBX. GLTF, export. Oh jeez. Jesus Christ. Okay. I might have messed up the scale. Oh lord. Oh lord. Okay, I might have to re-export the export, but yeah. Let's forget about this guy. So this is the correct armature. Oh, cool. And it uses GLTF, cool. I ended up reverse engineering Sasha Willems' animation code in this welcome to GLTF example renderer to figure out how to do this properly. Based. Based as hell. Oh god. It's just one absolutely huge... Oh jeez. It's just one massive... Wait, okay, it's here. Welcome to GLTF model. And what does he use? Tiny GLTF. Maybe I should use tiny GLTF when I think about it. Maybe I should. Maybe I should. I will consider it. I don't care. Get to the actual loading code, please. Mesh. Local matrix. Okay, let's go from top to bottom. Material we know. However, what I want to know about is primitive. Mesh. Primitive. Skin. Skeleton roots. Name. Inverse spine matrices and joints. Inverse the nodes. Okay. Inverse the joints, weights, and color. Maybe I should move to TinyGLTF because it's actually C++. Would make a lot of sense. Clueless, yeah. Render node. Okay. So I guess what you could do is have a uniform buffer for the camera, and then just push constant the local matrix. Like I think I really need to do scene graph before all of that. It'll probably make it easier. Render nodes, alpha masked primitives, transparent primitives, and sheep draws UI. That is a law code. Okay, so most of the code is actually just Vulkan stuff. Prepare, okay, we have all the nitty gritty. The overlay. Open GLTF file. A render using quaternions. I already have quaternions in my engine. It's actually not that long when I think about it. What about the shaders? Shaders. God, that is a lot of stuff. PBR alert. Okay, here it does all the... Okay, there you go. UBO node. Matrix joint count. And that's the skinning. God damn, dude. God damn. Even he even has his own I'm going implementation. What a flexer. He is one good guy. Okay, so what I'm gonna do is I'm gonna write myself some notes on what I learned today, and I'm gonna take a break and cut off stream because there was gonna be a short stream anyway. I just wanted to like read about it and like implement it at some point. It's gonna take a while to implement anyway. So let's make a new notes dots text. So models are composed, basically trees of primitives, of nodes that can contain a skeleton or a mesh, right? A mesh. A skeleton has a list of joints. A mesh has a list of primitives. Joints are related to each other via a tree, so that when a joint is moved, the other joints related to that joint move as well. The movement being affected by a weight factor found in the skin data, in the skeleton data. Those joints. Oh yeah, right. Each joint also has a inverse binds matrix to properly skin the mesh vertices when animating them. An animation is a set of translations, rotations / scales applied to each bone that can be interpolated using multiple different functions. Slurp, slurp. When an animation is played, we displace the bone's inverse binds matrix by the by a matrix calculated from the transforms of the animation and this inverse bind matrix is used to calculate the vertex position in bone space in the skinning process of the vertex shader. Right. Note that those vertices also have weights related to each other. Actually, no. Have weights in bone space to know how much they should move relative to the bone. So basically, there's weights between bones, and in those bones, there's weights between vertices. Okay, so, key concepts. So there's keyframes, bones, / joints, weights, bone space, joint space, model space, joint space, there's world space, local space, joint space, a skeleton, interpolation, inverse bind matrix, and skinning. Alright, I will read this over and improve it, and we'll read more about it next time, and we'll try to implement it. But yeah, I'm tired. It was going to be a short stream, because Life is Strange Double Exposure is dropping in half an hour, and I want to play it, so, yeah. But, it was, however, a really nice stream, and I hope to see you guys, probably tomorrow? If not tomorrow, for Friday. Friday is going to be a whole day stream, most likely. But yeah,
Anyway, bye bye.